So let's take a look at our water cycle map that we drew yesterday, and let's make some conclusions about what we see in terms of the pattern. Well, first of all, you might have remembered the elementary school water cycle. You guys have learned about this for a long time. It looks something like this. It's pretty simple. Water in the ocean gets heated by the sun, goes up, evaporates, condenses, forms a cloud, it rains, and the rain water eventually slides back off into the ocean. And that is a cycle. It is a very oversimplified water cycle. And that's what you were generally taught in elementary school, because that's kind of what you could handle in terms of your comprehension. But what we just did yesterday that we see over here on the right is a lot more accurate, a lot more real depiction of the pattern that water moves in our environment. And you can see it's not that simple. And this is actually still a somewhat simplified version of where all water can travel and where does it hang out in this water cycle. So the first thing I need you to do is I need you to copy these questions into your notebook, and we're going to answer these as we go through the conclusions. Leave enough space for each one so that you have space to write the answers for each one of these questions. You need to have this handy. So you've got this handy and you've got those questions. And here's what I need you to do first. I want you to look at that water cycle map, and I want you to answer these questions based on what you see in the pattern. You don't have to write them all down, or if you do, write them in pencil, because in case you get them wrong, but definitely leave some space where I'm going to go through these questions with you. But I'd like you to do this for yourself first. So pause the presentation at this time and just read through the questions, looking at the map, and get an idea of what you think the answers are. Okay, first of all, where are the locations where water tends to stay? And we denoted those on our water cycle map by putting little check marks up here. And you can see where we've got some check marks. Right here, glaciers. Glaciers are big frozen masses of ice or water on our planet. When water gets into a glacier, it hangs out there for a long, long time because it's cold. So it tends to stay frozen. And frozen water stays in place. It can't move around that easily. So that's why we see glaciers, or we say that glaciers are places where water stays a long time. The ocean right here. Our planet is 70% covered by ocean. There's a lot of water in the ocean. And the only water that can get out of the ocean is the water on the top that can evaporate when it's heated by the sun. Well, if you're water down here on the bottom of the ocean, you got to wait your turn. You got to wait a long time to get to the surface and then be able to evaporate. So therefore, when water gets into the ocean, it hangs out a long time. That's another reason why the oceans are so big, because the water gets stuck there. Another place that water tends to just sit and hang out are lakes and ponds, because the water's just sitting there. It's not going anywhere. It's just kind of hanging out. So once water gets into a lake or a pond, it has a tendency to hang out a long time. The one I couldn't show you a picture of is what we call groundwater. Now, groundwater is water that is found deep underground, and there is water down there under the ground. I can't show you a picture of it because there's nobody down there. But if you get the concept of like a well, where you dig a hole in the ground, eventually you dig down there and you reach some water, that's what we're talking about when we say groundwater. So these are all places where water goes and hangs out for a long time. Where does water not stay long at all? First of all, clouds. Clouds never last that long. You see clouds in the sky, they grow bigger and they grow bigger, they pick up more water, and eventually, usually pretty quickly, the clouds get so big that they have to drop their water. So the water goes up, the cloud gets bigger and bigger and bigger, and the water comes right back down. The lifespan of a cloud is measured in maybe days. No cloud lasts more than a couple of days before it gets so big that it has to drop all its water. Another place where water does not hang out very long is soil. And you see it right here. The ground is wet. There's water on the ground because it rained. Now, you know this from personal experience that the ground doesn't stay wet more than a couple of days. The water that's in the soil goes somewhere else. It either evaporates back up into the sky or it keeps on sinking in the ground and goes deep underwater. And we can see that here, our soil on our map here, the water either goes back up into the clouds, it evaporates. Our plants and trees suck the water out of the soil, or the soil keeps on sinking, goes in the groundwater. But either way, we know that the soil does not stay wet very long after it rains. Water at best stays there a couple days. Another location is plants. And we know plants have water in them, and we know that plants take water up out of the ground and they spit them out through their leaves, and the water goes back into the air. That process that we now know is called transpiration. Now, if you've ever had a houseplant, you know that you have to water these houseplants every couple days. Otherwise, they will dry out and die because water doesn't stay in plants that long. Now, there are some exceptions. You know, a plant like a cactus in the desert holds on to its water a lot longer than a typical houseplant. But still, we don't say that plants are a place where water goes and hangs out very long. People, animals. I'm going to use an example for you. If you drink a water bottle, you put water into your body and you're an animal, how long does that water stay in there? Not too long. Because you know if you drink a water bottle at the start of first period, you know, by third period or so, you're going and getting rid of some of that water into the toilet. So water does not stay in animals very long at all. Now, what was a location here where water moved back and forth the most? And on our diagram, we put little marks on the arrows. The place that we saw this happen the most was right here, between clouds and the ocean. Water evaporates from the ocean very easily, and we know that clouds dump their water very quickly after a few days, and most clouds drop their water right back on the ocean because 70% of the planet is covered by the oceans. So this happens all the time, constantly. Water is going back and forth. It evaporates from the ocean, makes a cloud, it rains, goes right back in the ocean. So this is where water goes back and forth the most. Now, let's talk about where water does not move. It doesn't go between all of these places. There are some routes on this map. Not every point is connected with the ocean. To answer this question, a pair of locations that water does not move between is basically the ocean and everywhere except a cloud. The only place that water comes from the ocean is to clouds. That's the only way for water to leave the ocean. It can't go into an animal because animals don't drink salt water. It can't go into a plant because we can't water our plants with salt water. Oceans don't go into rivers. It happens the other way around. So pairs of locations that water does not move between, first of all, is the ocean and every place except clouds. And that's significant because 70% of our planet is covered by water in the oceans, yet that water can only go one place, and that's to a cloud. Some other places, some other pairs, plants and animals. You'll notice there is no line between, we've got an animal over here, there is no way for water to go from animals to glaciers. There is no line that connects those two. And that kind of makes sense. There aren't any animals that live here on the glacier. It's covered in ice. The same is true of plants. Plants can't grow on a glacier. Therefore, water doesn't pass from a glacier straight into a plant. Plants can only take up liquid water through their roots in the soil. So this is a combination of locations where water can't go between. It can't go from a glacier to an animal. It can't go from a glacier to a plant. Some other locations. Let's talk about groundwater. That groundwater is deep here under the ground. Water from groundwater can't go to a plant. Now I know what you're saying, plants are in the ground, but plants, their roots are up here in the top part, which is called the soil. Plants can take water from the soil, but there are no plants deep underground. There are no animals that live deep underground. So therefore, water never goes from groundwater into plants or animals. It doesn't make sense. Another place, water can't go from the ground up to a cloud because there's no sunlight down here to make the water evaporate, which is what has to happen for that water to get into the cloud. Now, water up here on the surface, sure, that can evaporate and go to a cloud, but that's not what we're talking about here. So water does not go from groundwater to a cloud. Now, let's talk about some of these pathways, some of these places that are connected, but sometimes it's only one direction and not a two-way street. And here's one of the locations where water can only go one direction. Water from a plant can go to a cloud. The plants transpire, they throw water up into the air, and sure enough, that water can go up into the sky and help form clouds. But on the other hand, water from a cloud cannot go straight into a plant. Sure, it can rain on a plant, but that's not how a plant gets water. That's not how it takes water into it. Water has to fall into the soil first because that's where the plant's roots are, and that's how a plant takes in water. So this would be an example of a kind of a one direction or one directional relationship where water can only go from plants to clouds and not the other way around. Another example of that would be people. We sweat, and when we sweat, that water goes up in the air. Enough of that water goes up in the air, it can make a cloud. Now the reverse doesn't work. Sure, it can rain on people and we get wet, but the water doesn't go into people. So therefore, this is a kind of a one-directional relationship here. Water can only go from animals to clouds, not the other way around. Now, oceans and the river. We got the ocean over here, and here we've got our river. Rivers flow to the sea. Rivers are moving and they come out here and they dump their water into the oceans. Well, the ocean is a big pot of water. It's not moving anywhere. Ocean water can't go this way into the river. That's an example where water only goes one direction, only goes from rivers to oceans. Same thing here. Animals eat plants. Well, plants have water in them. The animals eat the plants, therefore the water is now in the animal. But this is a one-way street. Water from plants only goes into animals. The water in an animal can never go straight into a plant. Now, water from an animal can go into the ground, and then the plants take it up through their roots, but water from an animal can't go directly into a plant. Up here we've got a glacier. It's that frozen mass of water. And when it melts, it makes a river. Well, this melted water is never going to make a glacier. It's only the other way around. You get a glacier that melts, it makes a river, not the other way around. The only way water gets into a glacier is to come from a cloud. You can't have a river that flows uphill and backwards and goes into making a glacier. Animals and the ground or the soil. So when animals pee, the water goes into the ground. An animal doesn't drink water out of the soil. So this is a one-way relationship. Water only goes from animals into soil, not the other way around. Now, how about where water can travel both directions? Water can go up from the ocean, make a cloud. It can go from a cloud right back down to the ocean. And it actually does this over and over again. So this is a two-way street. Water can go both directions. Another example would be going from a river, and then we go into a lake. On the other side of the lake, we dump back out into a river again. This is an example where water can go from a river to a lake and then back into a river again. So it's a two direction, a both direction kind of movement of water in the water cycle. Now, this right here is what we call a natural spring. This hole out here in the middle is where water is coming up straight from deep under the ground. It's that groundwater, and it's coming out of that hole there, and it's making this little lake here. Now, some of this water, because it's sitting on top of the dirt, sitting on top of the ground, some of that water is actually going back into the ground. So this is a kind of a two direction. Got water coming out of the ground and then water going back into the ground at the same time. Here is the Chattahoochee River. Notice we've got some clouds up here. It can rain, and that rainwater goes in the Chattahoochee River. Chattahoochee River water also evaporates and goes up and makes clouds. So that's a two direction movement of water in the water cycle, from or between clouds and rivers. An example here, okay, so water is going into the cow, and then water will also come out of the cow. So we've got animals can take water from rivers and streams, and they can also put water back into rivers and streams. And that actually does happen. It's one of those two directions of water movement in the water cycle. Here's a glacier again. Now, glaciers are only formed when snow falls from the clouds and it piles up and makes this big chunk of ice. But ice is water. It can also evaporate. Glaciers, especially in the summertime, they evaporate and they can form clouds. So between glaciers and clouds is a two-direction example of motion. Now, water falls from the cloud, lands on the ground. This wet water over here on the ground is going to evaporate again, especially if the sun comes out. Well, if it evaporates, it's going to go back up in the sky. It can form another cloud. So clouds to soil is a two-way street. It's a two-direction movement of water. So we got all these patterns here. Places water can travel. It can go one way. It can go two ways. Some places it can't go directly from one place to another. The question now becomes, where does water enter and exit this map? Where was the line that water left glaciers and it just disappeared? It went off the map, or it was at a cloud and it just went somewhere else? Well, the obvious answer is there isn't any path. There is no path that shows that water leaves this water cycle, which is true. So where does water enter and exit this map? It doesn't. This means that water is always somewhere in this water cycle. It never leaves. Water's not created or destroyed. It's in there somewhere, and it doesn't ever leave one of these locations. Now it can move between the different locations, but it doesn't ever, we don't ever get new water coming in. We don't ever have water that leaves. So what does this tell you about water? Water's not created or destroyed. It is just recycled. It moves from one location to another. This also means that all of the Earth's water has been here since water was formed. About 4 billion years ago is when our Earth gained all this water. And for 4 billion years, that water has just been moved around, from plants to soil, to glaciers, to the ocean, to clouds, to groundwater. It's constantly moved around, but our water is 4 billion years old. It's not created or destroyed. This means that Dasani water bottle that you buy and you drink could have at one time been dinosaur pee. I know that sounds kind of gross, but dinosaurs drank water and they peed out water. That water went somewhere in that water cycle. And for the last hundreds of millions of years, it's been going from one location to another. Theoretically, we could be drinking George Washington's pee, theoretically speaking. Think about this. When you put water from your body into the toilet and you flush the toilet, where does that water go? It's not created or destroyed. It has to go somewhere else. Turns out we clean that water and then we put it back in the water cycle because we can't hold on to it. We can't take every flushed toilet water and just store it somewhere and say, oh, we're never going to use this water again. It doesn't work that way because water cannot be created or destroyed. So when you pass water, when you go to the bathroom and you expel some urine, that water, the H2O part of it, is constantly recycled and put back in the water cycle. What we do here is we send our water from our toilets to a water treatment plant where we take all the dirtiness out of the water, whether it's poop or pee. We take everything that's dirty out of your urine, and that stuff we dispose of. But the actual H2O that's in your urine gets put right back in the water cycle. In our area, we get our water from the Chattahoochee River. So after you flush a toilet, the water part that's in your toilet will wind right back up in the Chattahoochee River. And the Chattahoochee River flows downhill. People in Columbus, Georgia get their water from the Chattahoochee River after we've used it. So if you want to think about it this way, people in Columbus, Georgia are drinking our pee. Well, it's not really that gross as it sounds because it's not really pee. It's just recycling the water part. So here's the summary of what you need to answer all those questions. I didn't say every single one of these in the presentation, but for the answer to the questions, you need to have these written on your paper because this is what you need to have in your notes. Once you finish this presentation, it will be stamped done and you get credit for a classwork done stamp.